I want to talk about an important principle. It's sometimes referred to as the fundamental principle of rational numbers. That's a really fancy, kind of over-the-top term. Really, this is just an important thing you need to know about fractions. So, given a fraction, say it looks like a divided by b. Now, this has to actually be a fraction, so b can't be equal to 0 here. And a number c, where c is not equal to 0, we have that a divided by b is the same as a times c divided by b times c. Okay, so if I've got a fraction and I multiply the top and bottom by the same non-zero number, that leaves me with the same value. I have the same fraction. We're going to use this a bunch of ways. Let me give you a couple quick examples. If I wanted to simplify 12/18, the way I'm going to do that is I can recognize this is 2 times 6 divided by 3 times 6. And then from this property up here, since I have a 6 in the numerator and a 6 in the denominator in multiplication, I know that this is the same as 2/3. Okay, so the fundamental principle of rational numbers lets me simplify fractions when they have shared factors. If I wanted to add, really, or subtract 2/15 and 4/21, I will use this property to build these up so they have the same denominator. Specifically, I would rewrite 2/15 as 2 times 7 over 15 times 7, which would give me 14 1/5. And I would rewrite 4/21 as 4 times 5 over 21 times 5, which is 20 1/1. Sorry, 1/5. Did I say 1/5 before? I don't know. 14 1/5 and 20 1/5, and now I can do something with those numbers because they have the same denominator and I'm trying to add. If I wanted to multiply 8 63rds and 7 16ths, before I even did that, before I took the step of actually multiplying, I'm going to use this property and what multiplication means to break these things down, perhaps into something like 8 times 1 times 7 over 7 times 9 times 2 times 8, or something. Like, this principle allows me to work with fractions, given that if you multiply the numerator and denominator by the same number, you keep the same value.